the Congress by welcoming you, Rainer Russell. Dr. Russell has worked in the area of remote perception and GIS systems since 1993. He worked for 8 years in the German Aerospatial Agency as a researcher and also as a sub-director for optimal monitoring the environment. Since September 2005, he's in charge of the geomatics department of Congreso by leading the honor coordinating and remote perception systems. His main interests are monitoring environments and developing operational systems based on remote perception data and geographic information systems. For example, I will start again. We want to continue the Congress by welcoming you and Dr. Rainer Russell. Dr. Russell has worked in the area of remote perception and geographic information systems since 1993. He worked for an agency in research and for the automation and monitoring of the environment. Since September 2005, he's in charge of the General Direction of Geomatics of CONAVIO, the National Commission for the Knowledge and Use of Biodiversity, leading the coordinations of geographical information systems and remote perception. His main interests are monitoring the environment and developing operational systems based on remote perception data and geographical information systems. For example, for fires, for the changes in the soil, for oceanographic products and applications related to biodiversity and geovisualization of the spatial remote perception in the study of mangroves and the current system of the Mexican mangroves. Doctor, you have 50 minutes for your presentation. By the end, we'll have 10 additional minutes for questions. So please begin and welcome. Thank you so much for the introduction. Good afternoon, everyone. Before anything else, I would like to thank the organizers for this 5th Mexican Congress on mangroves. And here, I would also like to thank Tabasco's Autonomous University, as well as the Postgraduate College and the Mexican Committee of Mangroves, and everyone involved for the organization of this event. Because you're giving me this chance to present the works on the geomatics works associated to everything related to mangroves. So for me, it is great to be presenting my results here and the components of the monitoring system of mangroves, as well as other geomatics tools. I want to present the mangrove equipment that we use for remote perception. To begin, I would like to give credit to my colleagues, so I'm going to be sharing now my presentation.
¿Se me permite? Aquí, ok. Ahora ven mi pantalla, asumo.
Can you see my screen now? Well, I guess you do.
Bueno, al inicio me gustaría...
Well, first I would like to give credit to my colleagues that work on remote perception. They did all their work and they helped me with this presentation, and I am honored to be presenting this to you. I'm going to divide my presentation into 2 parts. First, I'm going to be proving some of the geomatics tools that we are developing with an approach of remote perception for monitoring mangroves, and later I will talk about some of the main components on the monitoring system for mangroves. In this context, what is geomatics? In general terms, it is a term that gathers the sciences from different disciplines that help for capturing, treating, analyzing, interpreting, disseminating, and storage of geographical information, which is also called geospatial or just spatial information. In this context, geomatics have different components in Gonavio, as you can see in this slide. Due to time limitations, I'm not going to focus on all of these topics. I will only be speaking exclusively about remote perception associated to mangroves and a little bit about geovisualization of this same information that we are obtaining. Some introduction slides. What is remote perception? It is understood as the acquisition of properties of a phenomenon without having physical contact with this object. This means the most simple way is our eyes. Our eyes perceive remotely on a daily basis, but when we talk about satellite remote perception, these are the satellites receiving information from an external source. In this case, it could be coming from the sun, or we have even satellites that emit their own energy, and they can measure the reflection over the earth through these radars. So in both cases, information after it is received, the satellite passes it through a direct readout station inland, and in Conavio we are using these types of stations for more than 20 years now for different sorts of applications. Once we receive this signal, we transfer all the information to digital numbers, and at the same time it can be proven through images, and that's the main supply that we have for analysts to work directly with this information on the reflection that has been measured directly through the interpretation of these calibrated images. Nowadays, we are using a variety of information through remote sensors of different scales, of different sources. Most of them are coming from satellite imaging. In Conavio, we are receiving many times a day, we receive information from different satellites from the United States, from NASA, and we are also complementing this information with other sources coming from other stations that are capturing information from more detailed satellites like Sentinel, Rapid Eye. And Dr. Reiser, I want to ask you one favor. The slides are not really on the screen because they look really small. You need to make it bigger. I will try again. It is. Let me check. I will try to share it again. Can you see it better now? Yeah, it's a little bit bigger now. It's not a full screen, but I can see it full screen in my own computer. Well, maybe. Don't share it as a presentation and minimize on that part of on your right. Try to minimize it as much as you can so you can manually show us your screen, because if you share it as a presentation, it looks very, very small. There we can see it perfectly. Maybe, yeah, exactly. That's it. Maybe we'll get a full picture now. Yes, I think that looks just fine.
I'm sorry, I don't really know why that happened because I can see it full screen. Anyway, I will continue. Please go ahead. It looks fine now. It looks large enough. So as I was saying, we are complementing the data that we receive from MODIS and VERS and different stations that receive Spot, Sentinel, Rapid Eye, etc., but also on scales, on aerial photography, and all of these group of information can help us identify and monitor different phenomena, and in this case, mangroves. Here we can see the different scales. As I mentioned, Conavio receives these images of medium resolution, 250 meters up to 1 kilometer, that we use for different applications, monitoring heat spots or thermal areas. But this helps us for very specific ecosystems. For mangroves, we would be using information of a higher spatial resolution, in this case, spots or Landsat or Sentinel images, and we complement that with other sorts of information like aerial photographs or hemispheric photographs that we obtain in situ. Nowadays, with all of these supplies, our archive has 600,000 pieces of data coming from different sources of remote perception, and 100,000 are coming from our own satellite station. Here we can see the impact. On one hand, we can observe that these low resolution satellites, like the ones up here, only give us a general picture on a national level. So it is quite useful for monitoring processes like fires on a national level. But if we have higher resolution, and for that we can monitor different ecosystems, and at the same time we complement that with in situ information that we obtain through the use of drones and other sorts of instruments. I'm going to be talking a little bit about drones in this slide. We use this information for obtaining better information on a local level of the mangroves and to differentiate between species, or to obtain geophysical information, and also to obtain information on the different structures of the mangroves. But it also allows us to monitor the effects of invasive species, like this weed that we are monitoring in Nayarit, with the arrival now of these problems that are affecting the mangroves. And we have large volumes of satellite information that doesn't really help to observe the impact of this phenomenon. Besides that, we use drones that can help us for very particular zones to create a cloud of dots, and through this cloud and these photo mosaics we can obtain accurate information on the height of the ecosystem of the mangroves, and at the same time this proves the capacity that comes from the information related to carbon. I will also be talking about carbon later on. And for example, this is a profile that was obtained through those drones that help us see exactly what's going on the canopies of these mangroves. This information at the same time can be complemented with satellite imaging, in this case from radar information. We started working in a project with the Geography Institute in Colombia, where we use radar data from Sentinel mainly to obtain information on the structure of mangroves, for instance, the size of the canopy, but at the same time to identify other sorts of wetlands and also to obtain information on the carbon on this ecosystem, and it also helps us to escalate that and to provide information, useful information for certain regions when it comes to carbon, because in this Congress we'll be hearing a great deal about carbon, because it also helps us comply with the different requirements for staying within the agreements. One new tool that we are developing now is geovisualization. By the end of the talk, I will show you some examples on virtual reality for different ecosystems. We have a prototype for mangroves, but geovisualization also includes other tools, and it helps spread and gather information from different disciplines in order to provide that for the community in general in really appealing and useful ways. So our information that is being generated in Conavio, we are visualizing and also disseminating through different tools. We have animations, 2D, 3D, and even 4D animations. And as I mentioned earlier, we focus a lot on augmented reality, virtual reality. This is an example of a coral reef and a mangrove in Quintana Roo. And geovisualization also includes our own portals like the Atlas of Society and Nature and the Geo portal, where you can access all of the results of geospatial information. Here we can see some of those tools. Perhaps many of you already know the Geo portal. We are working on the mapping on that portal. As of today, we have 186 maps associated to mangroves on a national level on this topic, but these are static maps. On the other hand, we have the Atlas, where we have now the possibility to research on mangroves in a very interactive way. So you can select your areas of interest and automatically you will be getting information in an interactive way. And as I said, here we can see some examples where we try to make this information accessible for people on different ecosystems that are difficult to get to. A coral reef and this place in Quintana Roo, in Siancan, in this biosphere, where all of this information is based on real information. We can see the classification here, where we obtained these images from. And virtually with all of this in situ information, we model the whole site so the user can move freely around the space and explore the animals and the different flora. Here are some screenshots. We have modeled the 4 different types of species. We have around 100 species that have been modeled that represent these areas. And as I said, this is an area of 3 by 3 kilometers and the user can move freely around it. You can get into the mangroves, you can find animals in there, and automatically you'll receive information on the different species in a visor if you have it, or in a desktop. Well, that was a really brief summary of some of the tools that we are using. And now in my second part of the presentation, I would like to talk more about the monitoring system of mangroves, and in particular, I will be talking about the components and the most important results that we have obtained. We started with this project in the year 2005 because Semarnat back then asked us about a reliable mapping on a national level. And in that moment, information was scarce, it was dispersed, as you can see on the table on the right, about distribution and size of mangroves on a national level. And the numbers were between 420,000 hectares and all the way to 1.4 million. So, with those numbers, making decisions and establishing public policies was quite difficult, and even less in a local or regional level. These numbers are useless. So Semarnat asked us to make a new mapping, an accurate, reliable mapping. First of all, about the extension and distribution of mangroves, but also to measure loss rates in this ecosystem throughout time. And practically, that's how this program for monitoring was born, with the purpose of having every 5 years a reliable mapping on the extension and distribution of mangroves. And little by little, this grew with an added value and several products that talk about changes, about threats, and the permanence of these changes in damage, mangroves and the recovery areas, all of the information that is useful now for decision making. In this context, the components of the mangrove monitoring systems are this. As I said, the main part of the base of everything is the mapping. Every 5 years on the extension of mangroves on a national level and the adjacent coverage. That's also important to see the drivers of change and the impacts around it, and also associated to the dynamic of the changes with the passing of time. Additionally, we are characterizing mangroves on a species level when it's possible, but also we are observing some areas of disturbance and deterioration, and we run analysis about connectivity with other ecosystems as well. And something interesting that we will be observing some examples about is the dynamic of the coastline associated to the mangrove zones in places that are that have a coverage of 65% of mangroves. So the dynamic is quite significant in this context. And in these past years, we have also gotten into understanding the social dimension. We can see not only the anthropogenic impact, but we are also coming up with some anthropization indexes. So we can see where the impact is, but what kind of impact it is, what type of infrastructure, or if it's tourism, aquaculture, and we can see some numbers later on. But all of this is useful and important information for public policies. And all of these, we do it in an isolated manner. We work with many of you. We work with the academia for a long time now. We have established a directory of specialists where in a joint way we organize events, national, international workshops in order to strengthen our area and the knowledge of this ecosystem. And how do we do that? Here, as I said, we start with this baseline in 2005, and we use satellite images. In this case, we got this information from Spot 5. We applied algorithms for surveil and non-surveil information. We have vegetation index here, and together we were able to obtain the coverage of the mangroves, but also of the surrounding areas. Here we can see the different classifications that came from each mapping. Once we established the baseline in the year 2005, we thought we are interested in knowing what is the situation of these mangroves back in the 70s and 80s. So we decided to go back in time and run an analysis for the whole country using aerial photographies that we obtained, that we collected, and we worked on them for the whole country. We had more than 2,400 aerial images that we worked on and that we calibrated and interpreted in order to come up with the classification of the mangroves, the distribution of the mangroves in the 70s and 80s, to have a historical background that could be compared now with the new inventories that we have every 5 years. And we did it for 2010, 2015. We used information from Spot 5. In 2005, we also used Spot 6 because Spot 5 did not have enough information available. And we also used Rapid Eye information because we don't have like a multi-license to use Spot information now. Unfortunately, for 2020, we had to change our supply, and nowadays we are using data coming from Sentinel-2 with this resolution of 10 meters. And the new 2020 inventory is on the way, and we are expecting to finalize it by the end of the year. This is an example of the mapping. Here we can see the mapping from 2015. We worked on this mapping scale of 1 to 50,000 with a minimum area of 1 hectare, which is enough for making decisions, regional and in situ decisions. And the accuracy of our product is around 90%. And on a national level, it's better in some areas than in others. Quintana Roo gets a little bit trickier, but in general, it's 90%. And for a national product, that is quite an excellent result. As we know that accuracy in 2008 and 2015, we have covered the whole country. We flew helicopters with the support of the Marine, the Ministry of the Marine, and we took like 250,000 aerial photographs, and we used that as an independent source for calculating the accuracy of the mapping. And we have also published all of that information in our geo portal and in the atlas. So we invite you to visit the atlas. Each one of these is a spot. You can see Veracruz. We have the different hemispherical images, vertical, oblique. Once you select one of these dots, you can see the metadata. You can see the image. You can download it. As I said, we did that 2 times. We have in total more than 250,000 of aerial photographs on the Mexican coastline. We can see some examples of these images, oblique, vertical. We also have video footage of some transects, infrared information that helped us interpret the information. What do we do with the information we obtain? Obviously, we get statistics, national statistics, and also state statistics. As you can see here, we have from the 70s and all the way to 2015 national numbers, but on a state level, we are monitoring the changes, coverage, extension, changes every 5 years, and we're publishing all of this information through the different supplies and publications that perhaps you know about. And nowadays, it's probably the best and most studied ecosystem on a national level, because we are also obtaining change rates per state as well for each time observation. We can see when we have positive or negative changes. So this helps us see the net changes, but we do not do it just to see the changes in this way, but it helps us find explicitly on a spatial level where these changes occur and where they're coming from and what's the magnitude of the changes. And we can observe that on this slide. We have some statistics here by state for the different classes. We can see the loss and the winnings here for each one of these classes between 2010 and 2015. And we can see that this is important because the net change in that time was of around 400 hectares, but in reality, the dynamics of the state was quite higher than that. So we can see that there were some surpluses here and some losses in other areas, and the net change was 400, but there was a lot of dynamics within the state, and this is relevant, and it is important to quantify the net change, but also to understand where we are winning, where we are losing individually. Here we can see another example, Veracruz, and the statistics, but I want to highlight that we do not only monitor the mangroves as they are, but also the different classes of the mangroves, because we can see that throughout time, there are some areas that perhaps do not have full losses of mangroves, but we see a lot of damage, decayed areas with mangroves, and we can see that clearly here in Veracruz, where the disturbed areas increased significantly in between the years 2005 and 2015. All of this information is being published through different books, different publications that you can have access to through our website. And we are including added value information, not only the extension or the surface, but also how many mangroves have what type of protection, how many mangroves are found in certain spaces, many kinds of and additional statistics on this ecosystem that can be useful. Besides the figures, for each one of the states in a detailed manner, we have the mapping here. We have digital mapping where we can download the information, or you can consult the information through the Geo portal or the Atlas, as I mentioned earlier. Well, finally, where are we heading now? We are in the midst of the inventory 2020. The goal is to finish covering the whole country by the end of the year. We have a great progress, as you can see now. Actually, we're only waiting for 5 states: Nayarit, Oaxaca, Veracruz, Campeche, and Quintana Roo. But we have significant progress on the month of October. We got to 90%. We are hoping to be able to publish the first results, extension and distribution of mangroves. And we are going to share that to the scientific community by the end of this year. Another thing that we are doing with remote perception is on the investigation of the timelines for differentiating between mangroves and the best conditions in the mangroves and the disturbed mangroves. Here we can see the impact on mangroves through a pond, aquaculture pond. We can see the behavior of the mangrove throughout time. We can see that for a long time it was quite stable, and suddenly there was a rupture here. We can observe that on the chart, and that's when the mangrove was removed to set the pond. So we see the drop there. This is done automatically for certain areas, and it provides indicators on these sudden changes, but also on slow changes. For instance, through natural phenomena or anthropogenic phenomena, it helps us to understand through these timelines. Here we have in 2005 a healthy mangrove. Then in 2010 we see an alteration. There is significant damage. We can see the signal that has dropped dramatically. Little by little, it was recovered, and the signal is getting back to similar uh, numbers. We can see this after the impact of hurricanes between 5 to 10 years. The ecosystems, if you let them, they can self-recover. Also, this is quite interesting. We are continuously working on this on the coastlines. Here's an example in the state of Campeche, in Punta La Disciplina, where between the 70s and the year 2020, we have lost around 1,000 meters of the coast area with coverage of the mangroves. So this is dramatic loss. And we can observe this not only in Campeche, but in other areas like Nayarit. And practically, we are obtaining this information and we are sending it to the whole country so we can observe the changes in the different states. I'm not in a presentation mode now, so you cannot see this interactively, but this is a slide where in the atlas that I mentioned, you can get into it, and for each transect, for the 65% of the country, we have 100-meter areas that you can select, and you can obtain the number of the loss in the coastline throughout time and the area associated through to that loss in the different observation periods. And we have that in global terms quantified. This is an analysis where we highlight the changes, the most significant changes in the country, and we can see some areas like Baja California, Nayarit, Campeche, where we observe losses of up to 1,000 meters. And we also have some dramatic surpluses here. Perhaps the sedimentation moved from one place to the other and it accumulated here, for example, also in the state of Campeche. And we do the same thing for the extensions of the coastline, but also for the different areas. So here in the same regions, we can see the most important areas that have lost or that have gotten better on a national level. And finally, I will be talking about the social dimension that I mentioned briefly before. We work closely with mangroves, and the anthropogenic impact is important, but what types of anthropogenic impact are we observing? So we divided that into different classes. We have airports, runways, settlements, construction areas, touristic areas, and of course, other types of impacts. And you can appreciate this in a really beautiful way, that the different regions, the North Pacific, that used to have a great impact, we see how that has been decreasing throughout time, while in the center it is quite dispersed. There's more dynamic and different impacts going on, while in the peninsula of Yucatan we can see strong impact on construction areas and touristic areas. And all of these statistics are not only there in numbers, but we have it spatially described for each polygon to understand where the impact or the change is coming from. And finally, we combine satellite information with in situ information. This is a compilation of information. We work with universities. In total, we are getting information from 315 plots distributed throughout the country, as you can observe there. And the information that we are collecting is information on species, but also on water quality, organic matter. 40 of these plots also measure carbon, and all of that database is being organized, and we are visualizing it through our atlas for its consultation. Nowadays, we have progress of 80%, and in the future, you will be able to select each one of the plots so you can obtain information on the structure, the physical, chemical information, and water, the soil, also production like organic matter or carbon, and that can be consulted by plot. On the other hand, I want to invite you to get into our Nature and Society Atlas. Here, you will be able to see the whole mapping. You can consult it in an interactive way. This is a beautiful example of the dynamic of the mangroves. We gather all the time layers, and now the user can consult on each polygon, and you can see the changes throughout time through a temporal profile, as you can see here. We can see here in the 70s and then in 2005, we can see that this is an anthropic development and it never recovered. We lost the mangrove there. So for each one of these polygons, we have these profiles, and this shows us the loss per mangrove, the green area, the stable areas, and the intermediate zones where we see fluctuation between mangroves and non-mangrove area. We can see deforestation and the dynamic, and everything is reflected on that atlas. So we invite you to take a look at it. And just one more slide. We are working in Laguna de Términos and in other areas where we have been able to obtain information in situ, mainly to prove the value of the ecosystem, because it is part of the blue carbon ecosystem, which is quite fashionable right now. And in order to calculate what's the content of carbon on the different mangroves, also aerial, but also inland, we have the different models, we have the different mappings in order to generate some scenarios based on the changes we observed on the ecosystem, the carbon storage, where are the areas for storing carbon, and also what are the emission areas. Finally, all of this information can be consulted in our website for the monitoring system for mangroves. This is a link. There's a lot of information to explore. And if you're interested in cartography, you can go into the Geo portal. We have 186 maps associated to mangroves. And very soon we will have recent information from 2020, and we have interactive information on the dynamics, the priority areas, or all the aerial photographs you can consult by state in the Nature and Society Atlas. And of course, we have published all of that information through different publications that are available online as well. And with this, I finalize my presentation. And I don't know, perhaps we have a couple of minutes to see a video of the virtual reality in Quintana Roo. You would be the first ones to see it. We are currently developing it. If you help me show the video, please. And with that, we can get into the Q&A session. after the short video. On the screen, perhaps it's not a good resolution, so you can really appreciate it, but I don't know if we have the sound. But this is an area of 3 by 3 kilometers in the north of Banco Chinchorro in the reserve of this biosphere. We have a sound on the video. The user can move closer to any ecosystem. You can consult all the information on it, information about the content of that virtual reality. Nowadays, we have around 100 objects that have been modeled. Plants, animals, the most important ones of the region. We can see some fish banks here. The user can get information on the type of fish. Now we are moving around the area and we have the lagoon here. We have obtained this through videos and photographs to get as close to reality as possible. Everything's based on real information. So it's not like other virtual systems that are just made up. All of this information is real. I can move within this space in a 3 by 3 kilometer zone. I can get close to the vegetation, to the mangroves, to an animal, and I can receive information about it. We can observe this in a desktop way. I can move around it like I'm in a video game, or if I have like an Oculus visor, you can see it in a 3D manner, in an immersive way, which is quite better and more shocking to see it like that, and you feel like you are really swimming around the area. I think that's enough. We can stop the video now, and we can get to the questions. Thank you for your attention. Thank you, Doctor. We are moving now to the questions. Yes, sorry, we are receiving the sound from the video, and it explains what is going on when you select an object. Okay, we'll stop now the video and we'll get to the questions. You should lower the volume because we hear the sound of the video. Please, you can pause the video now. So we can hear the questions. Very well. Most of the participants are saying that these maps of the GeoPortal are very useful, that you presented and that Conavio is making available for everyone. And they want to thank you for the presentation, and especially about these final topics, because you're giving us like an exclusive preview of observing this. And I want to add something to that in favor of the doctor, because himself and his team won an award on the geovisualization of coral reefs. And now they are taking that expertise to the mangroves. We have received some questions here. For example, what are the biophysical parameters, the most important ones, besides the height that you are obtaining through WAPs, through the drones in the study and monitoring of the mangroves? With the drones, we try to obtain density, the parameter on density and height, especially of the mangroves, and if it's possible to differentiate between different species. And as I also mentioned, specific impact like these threats that are present, but we calculate density and height mainly. One question that we received on the aerial biomass, is there a way to reasonably estimate the underground biomass of the mangroves? Well, the whole world would be really happy we were able to do that. As we know, carbon in the soil is much more important in these zones than aerial carbon. And I believe that there should be a correlation, and it is not easy. There are certain studies where they differentiate between different types of mangroves, if it's a gallery mangrove or any kind of mangrove. And with that, we perhaps could prove that there's more carbon in some types of mangroves than in others. And you also have the height information, but as far as I know, it is not that easy to establish a statistic relationship that could help us really understand what the situation is. You cannot just see the aerial situation and understand what's going on the soil, because it depends on so many factors, and it's not just about the aerial view. So it is complex, and it's not that simple to achieve. Another question that we are receiving, have you considered differentiating the agricultural changes, aquaculture changes, and livestock changes in the maps that you have of the monitoring system of the mangroves? Because we see that it's called agricultural and livestock, and on their own they could add important and valuable information. We could consider that. It would imply additional work for the shrimp areas. We have the cartography for, I think, for 2015, where we have observed that anthropogenic impact, and we differentiate there what type of impact it is. But in order to repeat that for each one of the cartographies for 5 years, it's a really large effort, because it would imply to interpret visually the different zones, and we do not have the staff that we would require to do that year after year. But at least we have it for the cartography of 2015. Very well. We have one more question from Maria Beatriz Barreto, who is asking, are you applying the remote censoring techniques for the impact of hydrocarbon spillage that might affect the mangroves? Well, we do not apply it to that. We have applied it in the past, but for completely different situations, for different accidents. Back then, we used satellite images for monitoring the stain, the carbon stain of the oil. But it never got to the coast, so we did not carry out an analysis of the impact in the Mexican coastline. And it would also require certain characteristics. The stain has to be large enough to be observed in satellite imaging. It should have a reflection, because it mirrors in the water. So we should be able to monitor it really. And if there are areas that have these spillages, in theory, we could be able to do it. We have small natural spillages that perhaps are not quite extensive, And through the satellite images, we cannot detect that, at least not with the supplies that we have now. There are hyperspectral and more fine products that might be useful for that, but perhaps for really specific areas. So I think here that for accidents or things like that, drones are the best tools we can use. Okay, thank you. And one more question. Regarding the validation of the category maps, can you present the information with confidence intervals that take into account the uncertainty and the area sampled? And have you done that in Conavio? If that is referring to the uncertainty of each class, then we did not do that calculation. We focus on the uncertainties and the certainties of the class of mangrove because that was our main goal. At the same time, in order to calculate that on a national level, you need stratification, a really broad one for all of those classes on a national level and interpretation of them. And this is a large effort to be more accurate about each surrounding class around mangroves. In theory, it could happen. We do not have the staff to do that. It is important for us to know the certainty and the accuracy of the most important classes of the mangroves. Well, we have several more questions. We're going to take a little bit more time. Giovanni Avila Flores is thanking you for the presentation and for your working group in Conavio. And the question is, what process should we follow to send spatial information to Conavio related to communities that are not within the monitoring system areas of mangroves? When you talk about communities, you mean about aerial information or information about the people? He's saying spatial information. Well, we receive all sorts of information, local, regional cartography information that can help us improve the accuracy of our local maps. Usually we follow certain cartography standards, guidelines for mapping, including metadata, but yes, you can get in touch with us, with the mangrove team, and we can see how we can incorporate that. A lot of the information in our geo portal is coming. We have more than 12,000 maps, and they come from external sources. And we have to make sure that the cartography standards and the information quality is secured. Okay, and if you allow me, one final question by Jorge Lopez Portillo. What possibilities do you have to get access to high-resolution images as well as access to Google Earth information? That's a difficult question. Access to satellite images, high-resolution images, it is getting harder every time, and that's quite sad because before there was a multi-license for the government on a national level for getting information from Spot, but that was not renewed. So the only data of high resolution that we have are coming from Sentinel and Landsat, but these are images of a few meters, but if you want higher resolutions, that's commercial data. And it would be good to perhaps think about a national license like we had before for Rapid Eye for 1 year at least, that provides all of that information for the academia in a free way. But in the current situation of the country, it is not likely to obtain that license. Well, that's terrible because in the beginning we had open sky and we had this possibility of different collaborations, and perhaps we could have access to that information. It should be available to us. All of the information coming from external or foreign sensors, perhaps we should be able to receive that. Yes, that's really complex, and we would need an extra talk to discuss that. Well, we have many questions that we are receiving now. There's another one. Are you updating the Conavio's website? Because it is not easy to find the mangrove site in there. Also by Jorge Lopez Portillo. Well, in the main link, well, not Conavio, because if you go to Conavio, you get to the government site. Biodiversity.com.mx, that is the main site. And if you put /mangroves, you can get into all the available information on mangroves. And just don't get confused between conavio.gov and biodiversity, because those are two websites. The supplies that we have is in biodiversity.com.mx. And another question, are radar images useful to find underground water sources? Yes, they are used in different places in the world, as far as I know, because they have the capacity to penetrate a few meters into the ground, depending on the soil's humidity. I think that for mangroves, maybe it's not the most useful tool. Well, for detecting water, yes, but not underground, because the substrate is quite saturated with water in the case of mangroves, so the signal won't get too deep into the ground. And I think that it's more like a useful tool for water, but for dry areas. In one of your slides, you talked about the losses and the surpluses that you are obtaining in your statistics on vegetation. You talk about the state of Veracruz, that there's a profit there of 400 with respect of the mangrove, but on the bottom, there was also a profit on the disturbed mangrove. So how to interpret that? Well, the two classes that we are interpreting, we do that individually. There are some areas that change between healthy mangroves and disturbed mangroves, so there's a fluctuation there. And in this sense, the numbers can be differentiated. I mean, some areas that we have classified before as a mangrove can change to a disturbed mangrove and vice versa. But also there are some areas with net losses and with recoveries, natural recoveries. So there are different ways of getting these statistics, but there's a way or several ways in which the statistics between healthy mangroves and disturbed mangroves can be differentiated due to the changes between them. And that's part of the interpretation that our specialists do to define if it stays in a healthy mangrove category or a disturbed mangrove. And that would also lead to an additional presentation to understand better these criteria. And finally, one more question. It says that you have been using optical centers of Sentinel A and B. And in this case, what is the role of the red age for you in the determination and discrimination of the vegetation, especially in mangroves? And what other bands would have this importance? That's a good question. The shortwave infrared, and the red edge, they are important for understanding the phenology and health of the plant, and also in mangroves. So that's why it was really important for us to work in the beginning with spot 5, because spot 5 had that channel and spot 6 didn't. So calculating the NDVIs, but also interpreting mangroves. Once again, we had other wetlands, and the shortwave infrared was really important, and it is one of the most used channels in our inventory for differentiating between mangroves and other wetlands. So Sentinel is no exception to that. It is really good because it has those useful bands that help us interpret the images. Well, we just want to say thank you. It has been a pleasure to hear your presentation, Dr. Reiner. A really interesting talk, and you work together with Conavio in this study and monitoring for the mangroves in Mexico. Thank you for that. Thank you all, and thank you to everyone that is interested in this topic.